series AI Special Interest Group online seminars, introduced by me, Richard Saldana. These seminars aim to explore a wide range of AI-related topics with invited experts, everything from algorithms and applications to ethics and AI explainability. It gives me great pleasure to introduce William Lovell from the Bank of England to you today. He is going to explore the technology challenges of implementing a central bank digital currency. Will is a senior advisor on central bank digital currency, data and payments at the Bank of England. He has spent over 25 years with the bank and has held a variety of positions from application developer and test manager through to heading up the bank's strategy and architecture function. Will is currently working on the design of a central bank digital currency, a digital pound, for the UK, with particular focus on the technology challenges that need to be solved. He is also co-chair of the bank's Artificial Intelligence Task Force, looking at how to make the best use of AI technology across the bank, as well as chair of the Committee on Payments and Market Infrastructures, focusing on, amongst other things, cross-border payments. Will.
That's great. Thank you very much. And thanks, everyone. As you said, this is a presentation about the challenges of technology for a central bank digital currency. So I've put together a short agenda that goes like this. First of all, I just want to talk about what the digital pound actually is, what the requirements for the digital pound are, because CBDCs in different parts of the world do look slightly different. Then I'm going to go really into the key technology challenges. And as we go, talk about the experimental work that we're doing in the bank right now and in the next year or so. Then we'll round it up by looking at what's coming next. But before I do that, I just want to do a quick intro to what the Bank of England is and how we think about central bank money, because I think it's important context for looking at the digital pound and actually those requirements and that technology. So first of all, this is the mission statement of the Bank of England. It's to promote the good of the people of the United Kingdom through monetary stability and financial stability. So that means monetary stability means stable prices, and financial stability means a stable system. And we do that by setting interest rates, setting policy, and by regulating banks. We also do that by printing banknotes and operating infrastructure. So creating a digital pound is the digital equivalent, if you like, of either printing banknotes, but it also represents operating infrastructure. So it's not a million miles away from the responsibilities that we already have. But a key component to being able to do this is central bank money, either in the form of printed banknotes or in reserves that banks use. And the digital pound will be a new form of central bank money. Interest rates are paid on central bank reserves. Settlement between banks happens through central bank money to remove risk. And to meet those objectives, money has to be accessible and usable. And it's very easy for very policy-focused people to start thinking about the exact design of how you want a system or a digital pound or something like that to work without realizing actually, particularly for retail users, it has to work. It has to be something that people can use every day in the way that they currently use banknotes. So let's take a look at what the digital pound actually is. And before I do that, we're just going to take a quick look at the difference between cryptocurrencies, stablecoins, and CBDCs, because this is something that I found that sometimes it's worth clarifying before we start. So a cryptocurrency is something that is exchanged over the internet, and its supply and its value is controlled by an algorithm. So the obvious example of that is Bitcoin. The amount of Bitcoin in supply is always controlled by an algorithm, and then the price goes up and down according to the demand for it. A stable coin is similar to that in being exchanged over the internet, but it's typically backed by some sort of securities or assets. Sometimes it's fiat currency, sometimes it's more abstract assets, and Tether is a great example of that. A central bank digital currency is, well, it doesn't have to be exchanged over the internet. It could go over other rails as well, but it's issued and managed by a central bank. So the key point here is it can have some of the properties of things like programmability that cryptocurrency or a stablecoin can have, but it's issued by the central bank and its value is managed in the same way by interest rate setting through supply and so forth. The most simple way to sum that up is that it's the digital equivalent of a banknote. And a retail CBDC, which is what I'm working on most of the time, is really the best way to think about that. And we think about central bank money as an anchor for confidence and safety. And this means that any design really has to think about not only everyday scenarios where people are going to be using this stuff, but also under stress and at times of sort of financial pressure. But at the same time, there's a great opportunity here to promote innovation and choice. And we're going to be looking a little bit at how we are planning to do that in just a few moments. The fourth but equally important thing is around financial inclusion. As the use of physical cash declines, it's important that everybody still has access to risk-free money. And that's something that we have to keep in mind. And with that in mind, I've got, I think, the only graph in this presentation. There it is. This is showing payment volumes between 2011 and 2021. And the declining line that you can see there, the black line, is the use of cash in number of payments. You can see that it comes down and it sort of starts to flatten out around about 2020. The upward line you can see there is debit cards, but all of the other electronic payment methods that are in there are starting to increase as well. And you can actually see that the crossover point between electronic payment methods and physical cash was 2017. So actually way before the pandemic, we were already starting to see in the UK and countries that have similar economies, this move towards electronic payments. So this can be thought of not least as our response to that trend that is already taking place. I'm going to talk quickly about CBDC as a platform for innovation, and then we'll get into what the architecture looks like. So first and foremost, a payment is only ever one half of a story. When you're paying for something, there is always some goods and services that are flowing in the other direction. But typically, the rails that money moves across are separate from the rail that you might receive your goods. Now, clearly, if it's physical goods, those will come maybe through a delivery, or maybe you're buying them in a shop. But even for online goods, if you're buying, for example, music or literature, things like that, the delivery methods are often quite separate. And there's a reason for that. It's typically because the ways we pay at the moment actually predate the internet. So there are ways to think about how to make payments more integrated and more seamless with purchasing, particularly online. The second thing is that payments contain more data than they've ever done before, and that has a lot of value. Now, it brings up some interesting questions around privacy and security that we'll take a look at in a moment, but there is some value there, definitely, both for the consumer and for providers as well. There are also a lot of opportunities to remove friction and to reduce cost. So this is not just a response to the decline in cash usage. There is also the opportunity here to start doing things a little bit differently. So what I want to look at now is our vision for the digital pound. And this is the, if you like, super high level architecture that we're looking at. This is something that's going to be used by households and businesses for everyday payments and online and in store. And we see it being accessed through smartphones and cards and accessible to UK and non-UK residents. We're not going to pay interest on it, at least in the first instance. So it'll be very similar to a banknote in that regard. But we want to make it seamlessly exchangeable. And there may be limits to how much a user can hold, at least in the initial phases, although the limits we've been looking at are quite high. But on the left-hand side of this slide, you can see this architecture. We see individuals and businesses then interacting with service providers, and then those service providers accessing a core ledger through an API layer. And there's some really important principles to this architecture. And that is that we want to make this a public and private partnership. We're not looking at the Bank of England to deliver every single part of this. The way that I often phrase this is that my job is really to worry about making a ledger that is really safe and secure and reliable. I'm not necessarily the guy who would develop an iPhone app that you would want to use, but there are lots of people out there who are great at developing that customer experience. So we want to have that competitive ecosystem. I think I have another slide on that. about here, that competitive ecosystem to provide different sort of wallet experiences and then bring that in through the API layer and into the central bank ledger. So that's the high level architecture that we have. We're going to take a quick look, hopefully, if I can make these animations work, at what a step-through transaction might look like. So here we have a person on the left and the person on the right who want to make a payment. And you can see their phones. We would trigger the payments going through the API layer, through into the central bank ledger, and then updating. And then we can see the person that receives them on the right-hand side. So that's quite a simple transaction. But let's see what a more complicated and more innovative use case might look like. It could be something like this. So here we have someone who wants to buy a parcel from the person who's over on the right-hand side, but they don't know each other. The person who's selling doesn't know if they're going to get their money. The person who's buying doesn't know if they're going to get the parcel. And some of the functionality that we're looking at will be able to do some sort of locking or escrow mechanism, where our purchaser, you can see here, goes through and then puts some money on hold on the ledger. The person who's sending the parcel can then see that the money is on hold and dispatches the parcel. And then the delivery agent can actually trigger the release of the money. So the person receives their parcel, the seller receives their money, but nobody actually has to take that risk somewhere in between the two. Now, again, this is quite a simple example, but it's the kind of features and functionality that we need to think about, particularly when we're looking at what we might need in the API layer and in the central bank ledger. So let's take a bit of a dive from here into what the current technology challenges are. I've got a list of 7 here. I tried to get the list a little bit lower, but every time I dropped something off, I just found there was a compelling reason to put it back in again. So I hope you'll bear with me as we step through these different areas that we need to look at. So the first is security and privacy. Then we're going to look at interoperability, because making the digital pound interoperate with other platforms is super important. I'm going to look at scale and performance, because there are some myths and some strange language that's often used to describe this. I want to get into that a little bit. And then we'll get into centralized or decentralized ledgers, whether to store the information in tokens or accounts, how we handle offline payments, and how we're thinking about programmability. So to begin at the beginning, let's look at security. Now, we have to think about security quite differently at the different layers. So starting at the top, it's going to be end user devices, phones and cards, similarly sort of technology that we already have there. Then when we're talking about having this competitive ecosystem of wallet providers, it's going to be important that they are operating the right level of security. And so part of the criteria for becoming a service provider is going to be being able to demonstrate that you can meet the right levels of security. Then at the central bank ledger layer, this is where we're recording the ownership, and this is where we need the really, really high grade security. This is where we're going to start seeing or needing to think about things like nation state attacks, things like day zero, organized crime, and those kinds of things, which again is the kind of stuff we need to be worrying about right now. So it's the thing we're probably best placed to do. But if we drill into that a little bit further, we can see what we have at the user layer for individuals or businesses. It needs to be lightweight. We can't start telling people they've got to carry hardware security modules with them. It needs to work with phones and cards and ordinary devices. And across a range of devices, we can't be tied into one vendor. We also need to start thinking about versions, because coming back to that inclusion point, if we force upgrades onto people at too high a rate, then that becomes very difficult. So there are a lot of considerations there, and it's important for us to work with the private sector and with those vendors as well. When it comes to access points, we need to be resistant to distributed denial of service. But as you can see, access to the actual ledger is really where we need the highest grade, and we need to start thinking about how we protect and recover against 0 days attacks. So I want to step from that into talking a little bit about privacy, if I can. So this is, at a very broad brushed way, how we think about privacy. And really, it's to think about boundaries, how information crosses the boundaries, and then what the people on either side of those boundaries need to know, and how you maintain privacy as data moves. And actually thinking about it like that helps us to think about the technologies that we need to use to enforce privacy. So the relationship between the users of CBDC, those individuals and businesses and the service providers, really should be able to have as much or as little privacy as you as a user of CBDC wants, or the service provider can offer you. They may well be able, in exchange for more access to your data, offer you products and services that you might like, in the same way that holding a loyalty card at a supermarket gives you discounts by sharing some of your data. But that doesn't mean that because you've shared your data with that service provider, it needs to be shared with the central bank ledger. So we think about that boundary and the privacy enhancing technologies that we might use for it. And in fact, this talk is well timed, because we published this week a piece of work that the bank has been doing with the MIT Media Lab on privacy enhancing technologies, specifically their application with central bank digital currencies. We go into that looking at pseudonymization, so using pseudonyms so that you can't immediately trace transactions to users, but also to things like zero knowledge proofs, which are a much stronger cryptographic technique, but come with a performance overhead, so need to be used in a slightly more complicated way. But what you can already see here is the trade-off between people who are happy to share more of their data in return for some sort of functionality, and people who want to do that less, and also the different grades of privacy and security technology we need as we move through the different layers. There's more work to be done on that, but if you're interested in the detail on that, then do check out the MIT paper. So what I want to talk about next is performance and scalability. And particularly this acronym or phrase, TPS, and transactions per second. Because one of the things I've observed when talking about payments and payment systems is people talk an awful lot about transactions per second. How many transactions per second have you got? And if you've got lots and lots of TPS, then all of your performance problems are solved. And what I'm going to hope to show you over the next few minutes is that that's not necessarily the right measure. And specifically, that there are different aspects to performance, and the aspects of performance are important in different use cases. And there are a number of engineering constraints, and we can take a look at those. So this is the place where I'm really going to see if my animations and slide builds are working properly. But here we go. So this shows a sort of typical process from payment initiation to somebody receiving funds. You have to check identity to make sure people are who they say they are. You have to do compliance checks to make sure there's no sanctions. You have to do balance checks to make sure people have got the money that to complete the transaction. You then need to make ledger updates and then notify everybody that that transaction has happened. And each one of those things takes some time. Some of them you can do in parallel, some of them less so. But the period of time all the way through is transaction duration. And actually thinking about transaction duration is often a lot more helpful than thinking about how many transactions per second you've got. And I'll show you what I mean. If we think about the purchase of a cup of coffee, which for some reason is always taken to be representative of every single transaction we might do. If you've got a spare moment, do try Googling cup of coffee and payment, and you'll see that throughout the internet that somehow the purchase of a cup of coffee is seen to be the test of all payment systems. I don't understand it, but I've borrowed it here. If you're thinking about that, actually, when you buy the archetypal cup of coffee in a coffee shop and you tap your card, these first few things, the identity checks and the compliance checks and balance checks, those happen very, very quickly. But actually, the ledger updates happen far more slowly. So when people are talking about the speed that card networks operate, they're normally talking about that first bit. And they're not mentioning actually that updating the ledger and somebody receiving some funds might take a day, even if the first part of it has taken a few seconds. So here we can see actually the duration starts to be slightly different from what we might have thought of done. Now, let's take a look at the other end of the scale. Imagine that you're operating a company and you're running the payroll for that company, and you've got to pay 100,000 people on the same day. It's a very, very large company, British Telecom or something like that. Again, the identity checks and the compliance checks for that can probably happen quite slowly because you want to get that stuff right. People want to have their pay accurate rather than necessarily lightning fast. The balance checks and notifications might take variable amounts of time, and the ledger update might be quite slow as well. But that's not necessarily important, because what you really want to know is that everybody's got the right paycheck and they've got it at the right time. Now, when you put these two things together, our cup of coffee and our payroll, you start to realize that transactions per second is really the less important thing. The last thing you want to be doing is purchasing your cup of coffee at the very second that 100,000 people are reaching their salary and you had to wait because that went through. You actually need to have a processing engine that deals with all of these different use cases and the way that people actually spend money and the aspects of performance that are important at the time that they're spending money. And there are engineering constraints on this. For every single transfer, you've effectively got to lock some funds as they come out of one wallet to make sure they don't exist in two wallets at the same time and both people don't think they've got the money. And that takes a finite amount of time. So you then need to think about which techniques you're going to use to make it work faster. Now, there are ways to go faster. I don't really have a lot of time. I thought I could do a whole session on this. Maybe I will one day. But the important thing to know is there are frequently trade-offs to getting things to go faster, either by batching lots of transactions up and doing them as a single entity, which might work for your use case or it might not. Or sometimes actually doing some of the processing offline, which again might work or might not. But really, in summary, what I think the takeaways are is there are different types of transactions and they have different needs. And there are some fundamental constraints that are going to influence our design. There are common solutions to addressing these problems, but they involve trade-offs. There's really no such thing as free performance, and it's not all about transactions per second. I've got a little science flask in the corner here, and that's to remind me that we're doing some experimental work on that right now. We're actually looking at different ledger structures, different databases, and different protocols to see which ones will perform in different scenarios. That's still work ongoing right now, but we'll be publishing something, I hope, within the next year in a similar way that we've published with MIT. Anyway, I should move on. I want to talk about interoperability and answer a few questions. So what do we want to interoperate with? What are the challenges and how do we address those challenges? So there are three big broad areas that we really need to think about here. First is working with existing payment systems. People need to be able to get into and out of the digital pound easily. Online systems and services, definitely, because this is going to be used not just for in-person transactions, but also for a lot of online business. And then also other CBDCs, potentially for cross-border, because there's a lot of opportunities there. I'm not going to go in depth into every single one, but really, in summary, oh dear, that's that. Sorry. We need to think about, first of all, message flows and data. And the important thing for message flows and data is that we have the right standards in place. Now, there are a lot of standards within the payment system already. And if we can start to use the standard, ISO 20022, particularly if you're a payment standard, if that's something that's of interest to you, this is something that people all around the world are starting to use. And it means that we can express the data and the message flows that come with different sorts of payments in a common way, not only across the world, across different systems. We're starting to roll that out in the UK. CHAPS is already operating on that, and we're starting to see it roll out internationally as well. think my slide has come out slightly strange here as well. But what I've got here on the left-hand side is also about rules and law. So by rules, I mean the rules that payment systems operate under, and the legal requirements that you have to meet as well. And this is particularly important for cross-border, where you start to see that what's required in different jurisdictions is quite different, and that actually making the technology exchange and exchanging the data turns into the more straightforward part, and actually getting the legal agreements to align is the more complicated thing. But once again, here we're doing some experimental work. Again, should be publishing in the new year, where we are looking at how we can integrate a prototype digital pound with the current payment system, so that you will be able to use the apps that you already have on your phone to be able to send money into digital pound wallets or transfer money out of digital pound wallets. We're also looking at cash integration and how we might be able to integrate with the cash network. If I was to sum that up, sending a digital pound to a physical pound is quite straightforward. Doing it the other way is turning out to be a little bit more challenging, but that is something that we're working on right now, and we'll be publishing some more on that in the new year. And really, to sum up on that, there are a lot of interoperability problems to solve. And the technology foundations need to be right to support those standards, but we also need to harmonise on rules. And again, this is a big thing that is influencing our design for technology. The piece that I want to talk about next is about token versus account. Now, this is really to do about how you represent a CBDC on a ledger. And this is often, as I hope this graphic shows, seen as a bit of a battle between two competing ideas. But actually, there's quite a few myths about that. So what I want to do is sort of step through and maybe bust a couple of those myths, and then just take a quick look at what the real differences between token and account-based systems actually are. So some of the myths are tokens are anonymous, and tokens can easily work offline, and tokens mean you're decentralized. That accounts cannot provide anonymity, can't work offline, and require you to have a centralized ledger. In actual fact, the best way to think about them is two competing data structures. Tokens typically have a fixed value and then an owner is assigned to that, if you often cryptographic token. An account has a fixed owner, which can have a variable value. And there are different advantages and disadvantages to representing the ownership of the assets in that way. But actually, tokens aren't automatically anonymous. It's very easy to make a non-anonymized tokenized system. And it's perfectly possible to make a decentralized account-based system. And we'll look at centralization, decentralization in a moment. But really, the most important thing is to understand that the use case that you've got, and how the different ways of representing asset ownership actually work in those systems. And it's perfectly possible to actually have a hybrid system that uses account-based most of the time, and then maybe uses tokenization for specific features. I will touch on that before the end. I don't know if I'm going to have time to go into it in much depth. But let's look at that data structure. So this is tokenized data structure. And what you can see here is that we've got an ID there, which is the ID of the token that can be cryptographically proved to have been issued by a central bank. So this is very much like having a printed banknote that has got anti-counterfeiting features in it, only it's applied cryptographically. It can have a fixed value, which means if you only want to spend part of the value of a token, some sort of change needs to be provided. There's a couple of ways of doing that. There's the unspent transaction output approach that Bitcoin uses. There are also other approaches where the central ledger will split a token into two new tokens, and there's pros and cons for those two approaches. You then give that token a wallet ID, and the ledger records which wallet currently has the token in it. Wallets can be anonymous, but if they're not, then that means you can track the ownership of tokens perfectly well. Those two concepts are slightly separate. Let's talk now about an account. An account ID can be cryptographically hashed to give it pseudonymity, and that's one of the things we were looking at in that privacy enhancing technologies paper. Actually, it doesn't necessarily need to have somebody's name in it, so even if someone gets access to that ledger data, they're not immediately going to know who has that balance, and then it holds a balance of assets rather than individual tokens of assets. So once you start to look at it like this, you can see that these are actually two different account structures, and really the decision between them is about how you want your CBDC to work. And either approach can work, and they have their own advantages and disadvantages, and a hybrid system is also possible. And again, I've put the flask down the bottom there just to remind me that as part of the database and ledger work, we're actually looking at token versus accounts and how they behave and perform in different sorts of scenarios. What I want to look at next is about centralized and distributed systems. So let's take a look at that. I think I stole that graphic from somewhere. So quickly, I think we should go for some definition. So in a centralized system, decisions are made by a single machine that is running a set of rules. So this is typically how a payment system, like how the CHAPS system works. And the machine is operated by one organization. Data might be replicated and quite often replicated over long distances to give geographic resilience, and there might be hot standby machines, but fundamentally the ledger is operated by one machine. In a distributed system, the decisions are reached by consensus of machines operating to the same rules. So this is what you typically see with the cryptocurrencies, but there are enterprise versions of that technology as well. The machines can be operated by different organizations. Sometimes they are, sometimes they aren't. And one of the attractive things about a distributed system is that processing and data replication come as part of the distributed design. One of the really interesting features of the cryptocurrencies for me as an engineer at heart is how resilient they have proven to be. You can keep knocking the machines out, but actually the network keeps going. And that obviously has attractions for something that needs to be operating 24/7, 365. And I try to sum that up in this sort of tick list here. Centralized systems can give you a tremendous amount of performance. If it is about raw throughput, you will struggle to be a centralized system. It's also very mature technology. We've been running centralized payment systems now for, well, real-time ones for probably 30, 35 years. And electronic settlement has been going for more than 50 years as well. So we know how to upgrade them, and they can be upgraded. Typically, you're upgrading a single machine and then moving the processing over. And I've put perimeterization here. I'm not sure if I've spelt that correctly, but the key thing here is that you can make a very, very hard perimeter, and you can protect that from cyber attack with very, very strong controls, which, thinking back to that security slide we were looking at a few moments ago, is super important. Decentralized gives you availability, and I put availability twice because I think it is such an important area. It also gives you immutability. If your data is replicated into hundreds or thousands of locations, it makes it very, very difficult for someone to go and change the information after the fact. It also gives you the almost opposite benefit of perimeterization, of deperimeterization, of making the perimeter so large that it's actually very, very difficult to attack, which is almost like a counter way to think about it. But it is an interesting thing to consider, particularly when you consider, again, with the cryptocurrencies that although there have been all sorts of frauds happening at the sort of wallet level, actually they've generally proved themselves to be very resistant to attack at the network level. So in summary, either approach can work, and they have their own advantages and disadvantages. And as with tokens and accounts, hybrids might be desirable to gain the speed of centralization where you need it and the availability of distribution where that is needed. And I've got my flask there to remind me to say this is again something that we're looking at in our performance paper and hoping to publish on soon. The thing that we have published on already is offline. So I want to talk a bit about offline payments. Now, you'll recall from a few minutes ago, we saw this picture of how our friend on the left is paying money to her friend on the right. But that, of course, requires the service providers and the API layer and the central bank ledger to all not only be available, but also to be connected. And if you're in the middle of the Lake District, or you're at the top of a mountain, or you're deep in a basement, that might not be the case. So what happens if those things are not available? How can we get a peer-to-peer transaction? So we've been looking at some technology solutions to that. We've been working with colleagues internationally as well, because if you think about a geography like Canada with large mountain ranges, this is something that they have really needed to put a lot of effort into. But in summary, the work we've done is a bit like this. It's really working on the trusted execution environments, either within phones or within cards, and then create a transaction that is then shared with the other user. Now, you have to have an eventual link back to the ledger. So at some point in the future, these two folks will go back online, and then those transactions will, with the right cryptography, the majority of the time will match, and we'll be able to say that's okay. We can now update the ledger to reflect the fact that that transaction took place. It does, of course, mean that until you've seen both sides and you have matched them, there is always going to be the chance that there's a mismatch. So we would need to have a process to handle those mismatches. And we're working on what that might look like at the moment. One of the things will be a limit on the number of transactions that can take place while you're offline. So the number of times you can pass that on, because of course, every transaction you do increases the likelihood of some sort of error or some sort of fraud taking place. That's really in high level terms how we've been thinking about this. The last thing I want to talk about is not as in the last thing I want to talk about. The last thing I'm going to talk about is programmability, and then we'll have a little bit of time for questions. So how do we think about programmability and smart contracts? First thing I want to say is about central bank programmable functions. So this is something that's generated a lot of concern, that somehow we're going to have money and that either ourselves in the Bank of England or someone in the government is going to put controls on what you can and cannot spend it on. And that's why I've put it in red here, will not be implemented. So we're in print on this, both on the bank's website and on the Treasury's website, that this is something that will not be built into the digital pound. We don't tell you how to spend paper banknotes or plastic banknotes as they are now, physical banknotes. We don't tell you how to spend those right now. And I've got absolutely no intention of telling you how to spend your digital banknotes either. So I want to be super clear about that. But there are some great opportunities to do automated payments, to have programmable wallets, to have delivery versus payment, like we saw with the parcel moving earlier on, and even smart contracts as well. When you start to look at the functionality that's available on platforms like Ethereum, you start to think what you could do with that with fiat money. I think it gets really quite exciting. So this is how we think about it. So starting off with in-app automation and integration with other services. So just the ability to trigger payments based on other events from other services that you might be connected to, like delivery services like we saw earlier on. But then integration with service level payments, so automated payments and subscriptions, maybe micro payments. Imagine subscribing to some sort of journal where you paid for each page that you read. Not really possible with the charging structure we have at the moment, but potentially possible with a digital pound. And then looking at smart contracts, escrow services, and hash time lock contracts that allow more complex integrations with other kinds of services. Again, we're looking to do some experiment work on this in the next year or so to start to really validate and elucidate what the use cases for this kind of thing might be. So I think I've taken up around about 45 minutes, which is what I said I would do. I'm just going to do a quick summary of experiments to make sure that I did mention all of the ones that I was hoping to, and then we'll have a bit of time for questions. But yeah, so the point of sale integration. So that's looking at how offline payments might be possible with cards, and also how we've shown how a prototype ledger could integrate with the point of sale devices that are already in shops and businesses. We published on that in May 2024, and there's some videos and some material on that on our website. And the Privacy Enhancing Technologies research paper came out this week. Do check that out if you're interested in. And then in 2025, the ledger technologies that's just looking at performance and different data structures, and also the interoperability with the current payment system, will be publishing next year as well. So I feel like I was going a little bit at lightning speed there, but I'm more than happy to take questions on any of that stuff, or anything else you might have on the digital pound. How do you want to do
Fantastic,
questions?
thank you, Will. I've got some questions in the chat.
Sure.
That I'll pose to you directly.
Yeah, no worries.
And then others may want to think about their questions. If you put your hand up, please keep your questions short. I will try and get round to everybody. So Mary asks, but let's start very gently first of all. Mary asks, is this ledger, this central bank ledger, using blockchain or something different? It sounds as if it was using something different.
I think it's likely to be something different. We will know a lot more when we've completed our experiments on the ledger technologies. I think to get the kind of throughput that we're going to need, particularly to support the speed of use cases that we're going to see in the UK, then some sort of high-speed centralized ledger is going to be required for that. Where I'm interested is in the programmability use cases, and particularly when it gets to things like hash time lock contracts. If you want to do smart contracts and stuff like that, actually having a distributed ledger is quite an attractive thing to have. So we could end up with a hybrid there.
Sure.
But yeah, watch this space because it's an area of active research.
Sure. I mean, it'll have to be a very fast ledger, as it were, because my understanding of blockchain is that it doesn't lend itself to lots of small value transactions.
No.
If a large transaction, it's actually a very good technology.
Yeah.
But it's going to sort of fall down when we're talking about the digital pound. If it comes.
Yeah, well, that's a good point. Yeah, we'll come back to that in a moment. Yeah, some colleagues in Sweden, so we do quite a lot of work with the Central Bank of Sweden, the Riksbank, and they described it as the stadium problem of lots of people converging on a sports stadium, buying a ticket, buying a hot dog, buying a souvenir, and you start to see a huge concentration of transactions from a single geography, with people who are not going to be very patient.
Sure.
Which is a great way to think about it.
It's rather like the mobile phone network being overloaded.
Yeah.
Certainly at sporting events, for example. Let's move on. So Frederick asks if one notifies a successful payment before it's actually recorded in the ledger, and I think you sort of suggested that is the case. But maybe you could elaborate a bit more.
Well, so what I was talking about there is how the card networks work. So when you tap your card for a card payment, particularly an in-person one, typically what will happen is it's authorized, which means that the first checks have taken place, but the actual transaction, the actual money hasn't moved on the ledger. And that's how card networks work today. And that's one of the ways they get that. That authorization means that a commitment has been made to make that payment. So various checks will have happened. What that does is enables you to take some of those constrained engineering things around the way that ledgers operate off the critical path of somebody standing there waiting to make a purchase. Whether we will need to do that in the digital pound or not remains to be seen. I'm hoping, well, we're anticipating that the transfer of funds with the digital pound will be much, much faster. So it will happen within seconds. Whether we need to have an authorization step to sort of get over those real peaks remains to be seen. We may be able to do actually the full speed thing.
I think it's important to distinguish between central bank digital currency, so fiat, electronic fiat currency, and crypto.
Yes.
And there's still a lot of confusion about
yes.
it. But is it just mining that is the difference, or is there more to it than that?
The mining is certainly a difference because it means that we will consume an awful lot less energy than something like Bitcoin, which is an important thing to note. But it's actually to do with the underlying value. So a fiat currency, like the British pound or the euro or the Japanese yen or the dollar or whatever it is issued by government fiat, and it has value, partly because it's broadly accepted, but partly because also you can use it to pay your taxes. Most countries operate monetary policy in a broadly similar way to the way the Bank of England does it. So we set interest rates which effectively make it more or less attractive for people to be lending pounds in the market or depositing them into the Bank of England. So by doing that, we can control the amount of money that is in, or we can attempt to control the amount of money that's in supply, which is how we tackle inflation. So the important thing here is that there's a group of people in the Bank of England who set the interest rate, and they do that to try and keep inflation constant. Now, I'm quite happy to take the feedback on how successful we are or are not at doing that, but the intent is clear and the intent is genuine. If you look at something like Bitcoin or the other cryptocurrencies, they don't know anything about inflation. They don't care. It keeps producing the money at the same rate as the algorithm says it's going to. Now, if you're a crypto enthusiast, you would say, well, that's better because I know that the algorithm isn't ever going to change its mind and is never going to change its policy direction. As a central banker, I would say, look at the actual utility of crypto. Trying to use it to take your wages and then plan your spending is close to impossible, because the amount of money that you'll have in your pocket could double overnight and then halve overnight again. The point of a fiat currency and the point of monetary policy is actually to try and maintain the value of a currency at a constant rate so people can plan what they're going to do with their money. So the difference is partly technical, but it's also partly about the purpose. And I do have to say, remind everybody at this point, Bitcoin has no underlying value. Its value comes from the fact that somebody else is prepared to buy it from you. And at the point that nobody is prepared to buy it from you, it really has no value. It's not like other assets.
I believe Mr. Musk was prepared to exchange Teslas for Bitcoin at one point. I'm not sure that that's the case at the moment.
Yeah, even he's maybe gone back on it.
Okay. Alex here asks about the e-Naira, Nigeria's central bank digital currency. It was launched in 2021, but he believes that less than 1% of Nigerians have actually used it. Would you care to comment on that? I think you speak to the Nigerian central bank.
Yeah, we do. Speak to a lot of our colleagues. I think so. I have a lot of respect for the Nigerian central bank for actually pushing ahead, and I think their experience has shown why actually planning and designing your CBDC is so important. Now, for a developing economy like Nigeria, the equation is quite different than it is for somewhere like the UK. In the UK, we have a mature payment system that day-to-day functions very well. It still needs investing in. There are still things that you can't do in the UK that you can do in some other jurisdictions. But for most people, most of the time, it's working quite well. So we have to position a digital pound against that. Whereas in Nigeria, their payment system and the way that it was working was much less mature. So there was more of an incentive to go quick and to go early. And what they found is that it's just positioned in the market has not had much take up. And this comes back to this thing that I was talking about right at the beginning, that there are all sorts of policy outcomes that one might want to achieve, but actually you've got to launch a currency that people want to use. So I don't see the Naira as saying that basically CBDCs will never work. What I think it's telling us is that the design needs to be right and the timing needs to be right as well. And you never know, that might come up quite quickly. Even faster payments in the UK, which is our instant payment system, for the first year or so was not broadly used. Contactless was not really broadly used for quite a long time in the UK, and then the use cases arrived, and suddenly, boom, everyone was using it. So I think the e-Naira may still have it today.
Thank you. Mary again, interesting question here. She talks about gaming in the sense that is there potential for gambling and future prediction markets to sort of game the system with a digital currency? Have you thought about those sorts of aspects?
It depends what you mean by gaming. I mean, the supply of the digital pound will work in the same way, actually, well, not exactly the same way, but in broadly the same way as the supply of physical banknotes does at the moment. So we have a total amount of currency in supply. And at the moment, physical banknotes are typically issued by high street banks who exchange reserves. So they hold reserves at the Bank of England. They exchange some of those reserves and they take banknotes. When they find they have more banknotes than they need, the banknotes are returned and they can get the reserves back again in broad brush terms. And this will be the same. The digital pound will actually not increase the overall supply of sterling. It will change the form that money is actually in.
Right.
So from a value perspective, it doesn't have a similar thing that you have with crypto where the value goes up and down with supply and demand.
Okay, thank you. There's a question here from Drago, and he's asking about the regulated liability network experiments. Now,
yes.
I might ask Drago to. So, would you care to elaborate on that? Because that's not an area of my expertise or understanding.
Yeah. So the regulated liability network, and I will invite Drago to put his microphone on, and please correct me if I don't characterize it correctly. So this is a group of banks, some international, some UK-based banks, who've got together and said, actually, how should we, from a commercial banking perspective, be thinking about these kinds of technologies, and the opportunity that particularly programmable platforms might offer. And they have done some experiments, I would say, largely in the wholesale finance space, so looking more at interbank payments and less so at retail than we've been looking at, so less so the kind of thing that people would use for everyday transactions. I mean, they are experiments, and I think they've shown some interesting results. The interesting thing about it is, I mean, I'm all for private sector innovation, and in fact, that structure that I've been using throughout my presentation shows how actually we want to work with private sector partners to create that sort of innovation. So I think that's quite good. Ultimately, where large amounts of money are moving and you start to create risks, that's where, as a sort of central bank, we need to sort of step in. So we're in active dialogue with the RLN about how their work might fit in with the work that we're doing, and that's something that I think we'll see expand through 2025. Drago, I don't know if you have a particular sort of angle or interest in RLN and wanted to ask a more specific question, but please do.
No, thank you. Answer is brilliant, and my conclusion is that there will be no wholesale CBDC yet. Thank you.
Okay. I mean, wholesale CBDC could be well, that is a whole other presentation because it's quite a different proposition, but maybe we'll get into that another time.
Well, we've got a few minutes. I'm not going to keep you too long. I'm just wondering if anybody would like to ask any further questions. Very happy for people to raise their hand, perhaps unmute, and ask questions of Will directly. Well, questions have been coming through thick and fast on the chat. I might just ask, in that case, I mean, I've got a final question of my own here. So I think we've all heard about Google's Willow quantum computing chip that has just been released.
Yeah.
I don't know all the details, but if this is a genuine quantum computing chip, as we know, most quantum computing is pseudo at this stage. Does this mean that all bets are off, Will?
I don't think so. Like you, I've been digging for the detail on the degree to which Willow is actually delivering the 10 septillion increase in processing, or whether it has the capacity to do that at some point in the future.
Mhm.
From what I've understood, the innovation in Willow is that they have got the error correction working much more, well, much better than I think some of the competing. Well, when I say some of the competing, I'm really talking about IBM here, because IBM have been leading the charge and have done some great work, and I know Google have done some great work too. It's quite difficult to see from the material that's come out so far, like I say, what's actually running and what it has the potential to do. I mean, I think the most important thing to learn about first and foremost is whether they can run Shor's algorithm, which is the thing that can do the factorization that breaks encryption.
Mhm.
And fundamentally, if they can break SHA-256 encryption, then I don't say all bets are off. I'd say a lot of bets are off. Yeah, a lot of people have to accelerate their upgrades a little bit faster. I do think, however, the headlines would be a little bit more dramatic if they had actually broken SHA-256.
I think you're right. I think one of the key features that they are claiming is that the addition of qubits leads to error reduction, or better error correction.
Okay.
And that hasn't necessarily been the case.
Yes.
Of course, with quantum, what we get is a probability distribution around the answer.
Yeah.
And so, you know, if that's the case, that is a genuine step forward.
Yeah.
But it remains to be seen what exactly they've got. Of course, I haven't got my hands on one of these chips.
Yeah, yeah, it does. And again, I don't think it changes the real world action that everyone should be taking, which is to come up with your, you know, do your cryptographic audit and make sure you know where all your encryption is, what encryption algorithms you're running and where you're using them, such that you know which ones to upgrade first as the different protocols are broken. I mean, I don't doubt that it'll happen at some point. The most important thing is to be, you know, match fit and ready, because the other thing that is moving apace is the post-quantum cryptography is getting, probably most importantly, a lot faster, so that the overhead that it used to present is coming down.
Well, look, thank you very much, Will. So, on behalf of the ISC and the audience present, I mean, it's thank you, a really informative seminar.
Thanks very much.
And if you've enjoyed this seminar, you might like to take a look at our istonline.org.uk website. We have another seminar happening in January. Watch out for an announcement shortly. And thank you all for attending.